మామూలుగా ఇది చూస్తాను మనం ఒకసారి పంపించేస్తాను 1 minute.
Uttar Pradesh stands a beacon of pharmaceutical education, Maharaja's College of Pharmacy. Guiding this esteemed institution and driving its pursuit of excellence is Principal Dr. M. Ramaya. Within its hallowed halls, the Pharmaceutical Analysis Department represents a critical nexus of practical chemistry. This department is dedicated to the precise identification, determination, quantification, and purification of substances. Here, the intricate science of separating complex components and definitively determining the structures of chemical compounds is meticulously taught and mastered. It is a discipline where unwavering accuracy is not merely an aspiration, but a profound necessity, directly safeguarding the efficacy and safety of medicines that touch every life. The department's mission is clear: to cultivate competent pharmaceutical analysts, professionals prepared to meet the rigorous and dynamic demands of the global pharmaceutical industry. This ambition is powered by cutting-edge laboratories, meticulously designed to serve the evolving needs of the pharmacy profession and the broader healthcare sector. A profound and practical knowledge of pharmaceutical analysis is passionately delivered by a dedicated team of enthusiastic faculty, wholly committed to the teaching-learning process. A foundation of advanced infrastructure. The department's robust infrastructure forms the very bedrock of its hands-on training, housed within 3 distinct purpose-built laboratory spaces. Lab 1, an air-conditioned hub of precision, features an impressive array of advanced instrumentation. Here, students engage with the Agilent Carey 630 ATR FTIR spectroscope and the sophisticated Agilent model -1220 Infinity LC high-performance liquid chromatography HPLC system. The lab also includes an Agilent Carey 60 UV visible double-beam spectrophotometer alongside essential tools such as pH meters, fluorimeters, conductometers, colorimeters, and a high-precision digital weighing balance. Adjacent to this, Lab 2, another air-conditioned facility, complements these capabilities. It houses a second Agilent Carey 60 UV visible spectrophotometer, flame photometers, and additional fluorimeters, potentiometers, conductometers, colorimeters, and pH meters. This lab further specializes with a Carl Fisher instrument for moisture analysis and an nephelometer for clarity assessment. Finally, the expansive wet lab LAB3 provides the essential foundation for classical analytical chemistry. It is fully equipped with crucial glassware, volumetric flasks, conical flasks, burettes, pipettes, and measuring cylinders, and supports broader chemical processes with a muffle furnace and a distillation plant. Driving innovation through learning and research. Beyond its physical resources, the Pharmaceutical Analysis Department thrives through continuous learning and impactful academic contributions. The department maintains a vibrant calendar of workshops, demonstrating its commitment to advanced skill development. These span critical areas from peer and group learning to intensive training on complex analytical instruments. Significant past events include faculty development programs focused on pedagogy and research challenges, along with specialized workshops on cutting-edge techniques like FTIR, chromatography, and HPLC troubleshooting. This dedication extends to the creation of extensive learning materials. The department develops video lectures, comprehensive lab manuals for both M-Pharmacy and advanced analysis and validation, and has authored textbooks. Notably, they also craft specialized lab manuals for industry partners, such as Dr. Reddy's employees, highlighting their direct relevance to the pharmaceutical sector. The department's distinguished faculty members are central to its academic prowess. Led by Drive North, numerous MOOCs courses, extensive participation in FDPs, webinars and conferences, consistently presenting their research on national and international platforms. Maharaja's College of Pharmacy in Vizianagaram, through its dynamic pharmaceutical analysis department, stands as a critical institution. It is here that the next generation of highly skilled pharmaceutical professionals are forged, ready to uphold the rigorous standards essential for global health and scientific advancement.
All the delegates and participants to the webinar, a grand welcome to all of you. Maharaja's College of Pharmacy, on behalf of our college, I am Dr. Anusha Pani, Professor. Welcome you all to the present online webinar on innovative FTIR approaches of TDM of biological matrices. And we hope that the webinar goes well and the participants take well the outcomes of the webinar. I request Assistant Professor Sweta Madam to please give the introduction of our guest.
Good afternoon, everyone. We are honored to welcome our exceptional academic and researchers to today's webinar. Dr. L. Surendrababu Garu, Assistant Professor and Course Coordinator at Adikavi Nannaya University College of Pharmaceutical Sciences, Tadepalligudem campus. With over a decade of teaching experience and a PhD in pharmaceutical chemistry from Andhra University, he brings unparalleled expertise in design and analytical research. His areas of expertise include chemical studies of bioactive metabolites, synthetic route development, and advanced instrumental techniques such as LCMS, GC, HPLC, and UPLC. His research portfolio is impressive, featuring over 19 publications, a strong citation impact with an H index of 5 and 6 patents in cutting edge fields like virtual screening platforms, fluorescent biosensors for cancer detection, and herbal based drug formulations. As an accomplished author, he has published textbooks and contributed chapters to recognized academic volumes, enriching pharmaceutical education for both undergraduate and postgraduate students. Beyond the classroom, he served as a reviewer for national and international journals and has guided several student research projects. His commitment to professional development is evident through his active participation in faculty training programs, conferences, and national seminars, many of which focus on modern teaching strategies, regulatory efforts, and computational modeling in drug discovery. What truly sets him apart is his blend of academic excellence and social engagement, having volunteered in health camps, youth initiatives, and national service programs. Today, he brings his deep insights to a webinar offering a valuable perspective on cutting edge innovations transforming therapeutic drug monitoring. Welcome, sir.
Pradesh stands a beacon of pharmaceutical education, Maharaja's College of Pharmacy. Guiding this esteemed institution and driving its pursuit of excellence is Principal Dr. M. Ramaya. Within its hallowed halls, the Pharmaceutical Analysis Department represents a critical nexus of practical chemistry. This department is dedicated to the precise identification, determination, quantification, and purification of substances. Here, the intricate science of separating complex components and definitively determining the structures of chemical compounds is meticulously taught and mastered. It is a discipline where unwavering accuracy is not merely an aspiration, but a profound necessity, directly safeguarding the efficacy and safety of medicines that touch every life. The department's mission is clear: to cultivate competent pharmaceutical analysts, professionals prepared to meet the rigorous and dynamic demands of the global pharmaceutical industry. This ambition is powered by cutting-edge laboratories, meticulously designed to serve the evolving needs of the pharmacy profession and the broader healthcare sector. A profound and practical knowledge of pharmaceutical analysis is passionately delivered by a dedicated team of enthusiastic faculty, wholly committed to the teaching learning
ఏం
process.
నాయన
A foundation of advanced infrastructure. The department's robust infrastructure forms the very bedrock of its hands-on training, housed within three distinct purpose-built laboratory spaces. Lab 1, an air-conditioned hub of precision, features an impressive array of advanced instrumentation. Here, students
అదేనా మన రూమా ఇక్కడ మేడం లేదు మేడం, ఒక్కసారి నాకు బ్లాంక్ పేజ్ కనిపిస్తుంది. నేను మళ్ళీ ఫోన్లో కనెక్ట్ అవుతున్నాను. ఒక్కసారి ఓకే ఓకే మేడం. లేదు మేడం, రాలేదు. కనిపిస్తున్నాను మేడం ఇప్పుడు. మేడం సరే హుషారు మేడం. ఒకసారి మేడం కాల్ చేయండి. Good afternoon to everyone. Thanks for giving the introduction about me. Today we'll discuss the topic regarding innovative FTIR approaches for therapeutic drug monitoring in biological matrices. Where the spectroscopy plays an important role in diagnosing of the various kinds of diseases, where the spectroscopy is a study of electromagnetic radiation, how the electromagnetic radiations such as visible light, heat, or X-rays is observed and reflected by the matter, where a spectroscopy splits the energy reflected by an object into a different wavelength is nothing but spectra to reveal the information about the objective, where the UV range is 200 to 400 nanometers, visible 400 to 800 nanometers, IR here near IR 0.7 to 1.4 micrometers, shorter wavelength IR 1.4 to 3 micrometers, where mid IR 3 to 8 micrometers, a fingerprint region, and far IR wavelength is 8 to 1 millimeter. Apart from this, where the rotational waves, nothing but a microwave, 1 millimeter to 30 centimeters nuclear spin and electronic spin comes under the radio waves, where it is 100 meters to 10 meters to 200 meters. Where the wavelength is inversely proportional to the energy, where wave number is directly proportional to the energy, where wavelength can convert it into wave number by using a formula centimeter inverse by 1 by micrometer into 10,000. Then coming to the next slide, here uh, spectroscopy of measuring techniques like transmission and the reflection. In transmission and the reflection, the traditional techniques are there, where reflection, spectacular reflection, diffusion reflection, and total internal reflections are there. Where apart from this, it's having a sample holder, source, and detector. All these spectroscopies, based upon the range, they are categorized. MIR, FTIR, DR FTIR, ATIR FTIR, and Raman spectroscopy, where all these works under the principle of covalent bonds which is existed between the organic and inorganic molecules, where absorbs the frequency of electromagnetic radiation, the molecule undergoes vibrations and with the presence of dipole moment and amplitude, where the frequency with the speed of the light and the wavelength based on the E is equal to hv. At a lower region, at a lower electromagnetic radiation gives a nuclear electronic transitions within the frequency, where the vibration IR within a wave number can be given, where IR spectroscopy reveals the structure of organic molecules. The basic principle involved in the FTIR is vibrational spectroscopy, which observes the IR vibrations and gives transition to reveals the information of reveals the information of functional group determination and the molecular structures, where the energy of molecules is equal to electronic energy plus vibrational energy plus rotational energy. When coming to the uh, chemistry behind the molecules, which fulfills the natural vibrations which is existing in the molecule. Next slide. Where the dipole moment, the product of charge which is act in between the perpendicularly to the distance between two atoms, and this can be calculated by coulombs in SI units, where a symmetric diatomic molecules of nonpolar like O2, N2, and it doesn't release the IR spectrum because of there doesn't exist the dipole moment, where vibrations between two atoms in a molecule, it will be based on the principle of Hooke's law, where the two atoms considered as a masses when it is connected with a spring, structure of this spinning, it's beyond its equilibrium distance. The potential energy increases on its kinetic basis, changes continuously, and harmonic oscillations will be occurred, where energy oscillations directly proportional to hv oscillations and gives the vibrations, where force constants for the carbon single bond carbon 5 into 10 to the power of minus 5 dynes per centimeter. Carbon, double bond carbon, 10 to the power of 10 into 10 to the power of minus 5 dynes per centimeter. C triple bond C, 15 into 10 to the power of minus 5 dynes per centimeter, where the increasing the order, which indicates that increasing the frequency of vibrations from triple bond to single bond. It indicates that it indicates that with lower frequency of vibrations, where stretching of CH bonds at 3000 centimeters, which produce more frequency of vibrations than carbon bromide at 600 centimeters, where bendings occurs at a lower energy frequencies. Then coming to the next slide, when coming to the slide, where the vibrations uh, is based upon the either dipole, moment, motion, and resonance. The more the bond length, the more the bond length or the conjugation will cause reducing the force with constant absorption with moving towards a lower frequency, where this can be categorized with energy levels or the vibrations like stretching vibrations and bending vibrations. These are uh, stretching vibrations, symmetric and asymmetric, and these are again uh, further categorized into scissoring, rocking, wagging, and twisting. These are comes under the bending. Then coming to the next slide. Then coming to the next slide. Uh, in IR spectroscopy, the vibration, most of the all molecules undergoes vibrational rotations, which will be uh, directly observed the changes the movement of molecules by the dipole, where the source, which is commonly used. Madam, fifth slide. Excuse. Better. Yeah, yeah. Where the sources are commonly incandescent lamp, Nernst Glober, nichromium wire, and mercury arc lamp. Here are the sources where nichromium wire coil, which is wounded with a black oxide film, which can withstand heat for 1300 radiation. Nernst global fused with mixture of earth metals, zirconium, thorium, and Vt. Globar sinter silicon carbide rod, where mercury arc lamp which withstands with 1000 degrees. When coming to the monochromators, prisms and the gratings, in prisms, single pass prisms and double pass prisms, where double pass prisms is used uh, for more resolution for powders, and it is made up of calcium fluoride and lithium fluoride. Where gratings, which are made up of aluminum sheet containing a closed uh, equal grooves made up of glass and plastic. Where sample cells Sample cells. In sample cells, are mainly made up of metal halides, sodium chloride, potassium bromide, and cesium bromide for non-aqueous. For aqueous, lithium fluoride, calcium fluoride are used. Where sample preparation, it undergoes four techniques: pressed pellet technique, mold eugenol technique, and sample film technique, or mountable cells, demountable cells, and flow through cells, minimum cavities are used. In commonly, here the detectors which are used is thermal detectors and photo detectors, where thermal detectors uh, thermocouple detector which having two junctions with a hot junction and cold junction, where rays which are reflected onto the hot junction, which is recorded and sent to the cold junction, which is enclosed within a KBR, where the current is directly proportional to the energy difference. Where bolometer, it is works on the principle of Wheatstone bridge, where it is nothing but change in resistance, which is detected in galvanometer. Gole cell, the cylinder which is enclosed within a xenon gas, whenever the reflected rays which are incident on the diaphragm of the metal, which will undergoes expansion. After expansion, it will record at the spectra, where pyroelectric cells is consisting of crystals which are made up of barium titanate and lithium nicobate, lead nichromate, lithium phthalate, and triglyceride sulfate. And these are commonly used when photodetectors, which are classified into two types: photoconductor detectors and semiconductor detectors, where semiconductor p type and n type are present. When coming to the Fourier transformer, in Fourier transformer, uh, lithium neon laser, which is used to control the uh, movable and the stationary mirrors, which is particularly to incident on the to the sample to give exact single ray beam onto the sample and gives intensity versus wave number. When coming to the next slide, where whatever the spectrum which is recorded with noise, which can be incident 25% to 50% and 75% based upon the absorption, it will be gives the illusion of the peak. And coming to the next slide, and coming to the next slide, the uses of uh, IR spectrum in chemically, pharmaceutically, and biological biomedical fields, where the chemically material identification, characterization, reaction monitoring, and quality control, and polymer materials like material sciences and green chemistry, where pharmaceuticals, drug discovery and development, quality control and stability, drug delivery systems, and drug detection and pharmaceutical analysis, where biomedical field, a diagnosis, tissue imaging, and extracellular vascular analysis, and biomaterial characterization, targeted drug delivery systems can be identified by using FTIR techniques. Next slide. The applications. Next slide. IR spectrum, basically it gives the based upon the vibrations of the molecules of biological samples with the fingerprint advantages and multivariant data analysis technique, which gives variation in pathological condition of the biological samples. For example, carbohydrates. For example, carbohydrates. For example, carbohydrates. Uh, it is like 950 to 1200 centimeter inverse, where polysaccharides 1140 to 1180 centimeter inverse, glycosidic case 17.5 to 1140 centimeter inverse, nucleic acids 1800 centimeters to 800 centimeter inverse, where nucleic acid phosphorylation changing 1300 to 1000 centimeter inverse, where when it is attached with the sugar moiety 1100 to 900 centimeter inverse. Here, the stretchings of hydroxyl group NH and CN can be realized at 3,800 to 2,000, 2,300 centimeter inverse. Most of the nucleosidic bases, adenine, guanine, thymine, at 800 to 500 centimeters inverse can be observed, where glucose 1500 to 500 centimeter inverse in mid-air we can be seen. When creatine 1720 to 1556 centimeter inverse can be seen. Based upon the variation of the pathological condition of the disease state person, by the variation of the position of the functional groups, we can identify and the diagnoses the person with variation of these bond lengths. And I will explain some of the bond excite regions for the bond lengths. For 4000 to 2500, 3600 hydroxyl groups, 3500 amine, 3000 CN bonds, SH 2500, where C triple bond and 2250 centimeters, where single bond C triple bond C 2150 centimeter inverse, where C double bond C at 1800, cyanates at 1100, C double bond N at 1690, C double bond C at 1650, C double bond sulfur at a range of 16 to 1500, and last 1500 to 400 centimeter inverse, like halogens from 1300 to 1000. This can be lies, where some of the anhydrates, the peaks will be to 1820 centimeter inverse to 1760 centimeter inverse. Acid chlorides, 1800 centimeter inverse. Esters, 1735 centimeter inverse, where aldehydes at 1725 centimeter inverse, ketones at 1750 centimeter inverse, carboxylic acids, it's nearly 1710 centimeter inverse, amides 1690 centimeter inverse, alcohols 3600 with broad peak with nitro groups. It is lies nearly at 1390 to 1300. Hydrocarbons hydrocarbons at mm, at 2000 range with the aromatic hydrocarbons. Next, when coming to the applications, uh, when coming to the applications in medical field, basically it is used for chemical characterization, and it reveals the biological substance such as proteins, lipids, nucleic acids, and carbohydrates. Mainly, it gives the identification change in the blood components like hemoglobins and viral infections and total cholesterol. Uh, Apart from this, the constant monitoring of glucose, conjugated viral growth of herpes infections, ATR FTR spectroscopy was also used to identify the hepatitis C and hepatitis B viruses and dengue fever, which is caused by the viruses. And FTIR spectrum demonstrate the valuable tools for detecting and characterization of cell death in leukemia cells. FTIR spectrum can use to quantify the urine components like proteins, uh, creatine, and urea. And coming to the next slide, the advancement of FTIR is ATR and microsampling, where ATR is an uh, investigation of molecular composition of materials, and not only it gives the importance of chemical bonding as well as functional groups present in the sample. But here, the sample preparation is not required, where microsampling uh, in Fourier transformer FTR is a powerful analytical technique. It is used for material characterization. When coming to the next slide, it stands FTR techniques, where uh, it is used for identifying the raw material uh, and quality control and scientific research. An ATR crystal, which is whenever the sample which is adhered, which should be in a good contact to gives internal reflections and partially absorption of sample on the top. Uh, Due to the waves observed with a less optically less dense samples to advancing the field of IR light interacting with the sample. Whenever the advanced field decay the exponentially and the light only interact with the few microns and carries the absorption information to the detector. And coming to the next slide, comparison of ATR R spectrum with IR, where generally it shows the band pattern with a sampling of emission of spectrum. But the difference that doesn't allow the direct comparison of ATR spectra, all wavelength must pass through the same total thickness of the sample. But the light functions the wavelength and the reflection. This is the spectrum which is obtained from the Broker software. The band intensity of the same material at different wavelength can be transmitted by ATR. Technique. Uh, Techniques, a small amount of sample which is introduced in the ATR crystal, a powder sample should be applied a pressure to ensure the contact on the ATI crystal. High pressure of ATI used to analyze very hard and larger sample. The liquid requires no additional pressure. Uh, Hand stitching is applied for pressure robustness diamond ATR crystals. Sampling is quite easy. A liquid sample is easily filled into a sample tray. The pastes are added to the crystal and spread within a spatula. And coming to the next slide, the different ATR crystals are there. Monolithic diamond as an ATR crystal material, but is not suitable for analyzing the samples with unusually high refractive index, like that is black carbon filled rubbers. And coming to the next slide, germanium as an ATR crystal. Madam, 15 slide. Next slide, madam. Germanium as an ATR crystal material. Here, the narrow spectrum range comparing to the diamond of zinc selenite, where it is suited for a high resist microwave FTIR, useful for investigation, very thin layer of sample surfaces for strong absorption of dark materials. When coming to the uh, zinc selenide ATR crystal, next slide, where it is relatively a cost efficient, affordable, and relatively broadly accessible spectrum range, commonly used for acidic samples, will generate toxicity of selenium hydrate. Next slide. Where the IR beam bounces within the ATR crystal and interact with the sample with multiple times. Upon multiple times of incident angle on ATR crystal plate, which increase the sensitivity of for weak absorption of sample at low concentration, gives a significantly doubling of bouncing. Observing the intensity will increases by a factor of 2, where it is commonly used uh, in the forensic investigation, reaction monitoring, and cannabinoids differentiation and analysis of raw materials and finished products. When coming to this sampling and matrix, we can we can take whole blood in a EDA, EDTA tubes and dry sampling blood spots, plasma, serum, urine, and saliva. We'll see first whole blood how we will collect. Blood sample was collected from a patient in a EDTA containing tube and separated the plasma by centrifuging 1500 rpm for 10 minutes at 4 degrees, and eloquent was kept for 80 degrees. After that, 25 degrees room temperature at water bath for 30 minutes and place the sample in zinc selenide substrate to emission by HAR, where 10 minutes of emission mode, it will gives a constant film formation where all the substrates of the crystals were carefully cleaned with an optical graded acetone and ethanol to prevent the contamination between the samples. Next slide. Solid extraction phase. When coming to the solid extraction phase, when coming to the solid extraction phase, here we discuss the how the blood collection. Next, tissue collections, where collection of tissues, horizon and dewaxing with the xylon and dried and mount directly on ATR crystal. And we can visualize the spectra. Next, cells. Kryptonization with cells washed and resuspended on ATR crystals. Air is washed with acetone and distilled water, dried under laminar airflow, and this analysis was directly placed on the ATR crystal to give the spectra. All these tissues, cells, and air, these are air dried under the nitrogen dryer, which is commonly used to eliminate the water which is present in the samples. Next, solid phase extraction. In solid phase extraction, condition, loading, washing, elution, and collection, based upon the pre-concentration of analyte, make easy to detect the FTIR, where it leads the more accuracy of analysis and minimum amount of solvent required for comparison of extraction of traditional liquid-liquid extraction methods. And coming to the next slide of liquid-liquid extraction, protein precipitation. In protein precipitation, step 1, proteins were pretreated by using buffer and cleaned. After that, they are kept for 3 hours for dry. And third step, and they are assembled with calcium fluoride, liquid cells. Then they are placed to the HAR to give the spectrum. And later the data was uh, characterized. Next, liquid-liquid extraction. In liquid-liquid extraction, to improve the noise signal to the noise ratio in the FIR spectrum, allow the detection of low concentration, where interfering the sample matrix and simplifying the FTIR analysis, and removing the interference of the compounds and minimizing the matrix effect that can affect the accuracy of FTIR measurements. And coming to the next slide of challenges to quantify the drug in biological samples. Uh, the complexity of biological matrix like plasma, serum, and urine. The interference from the proteins and the lipids and other biomolecules need for high sensitivity and specificity, where when a drug administered from site to the systemic circulation to the collection of the sample from the patient to increases the selectivity and drug concentration, the collection of analyte is more important during the period. Next, advancements of FTIR technique enhancing the therapeutic drug monitoring. Fourier transformer spectroscopy has emerged a powerful technique tool in medical research, offering non-invasive and precise examination of molecular composition of biological samples to emphasize its ability of molecular fingerprint and assist identification of biochemical structures and key peaks in biological samples in ATR, FTIR images gives the distribution, a drug distribution in the tissues and pharmaceutical tablets offering microscale insight. Time resolve FTIR, it is used for dynamic compression of monitoring molecular dynamics in real time release rapid biological changes, where FTIR nano spectroscopy gives a chemical characterization in nanoscale to study the heterogeneous of biological samples at high granular levels. Then coming to the next slide, whenever the multidisciplinary clinical specialists to improve the patient care, whenever the dose is administered during the clinical trials to improve the outcomes and in the population, the priority information post measuring of the blood concentrations like pharmacokinetic and pharmacodynamic dynamic monitoring like narrow therapeutic index like long-term therapies correlation with the concentration of serum and their clinical responses inter-individual and intra-variability of pharmacokinetics biomarker association with therapeutic outcomes and administration and other potential interactions with the compounds can be seen. Then coming to the next slide, the pharmacokinetics drug distribution. absorption. Whenever the drug enter into the systemic circulation, it will be absorbed and again redistributed to entire systemic circulation. After that, it will terminated from the body, where the plasma drug concentration predicting receptor concentration and the receptor drug concentrations can be predicted the responses, where the factors to be considered during the therapeutic drug monitoring, uh, mainly dosage resume and duration of the therapy, patient complaints, drug interactions, alcohol or tobacco users, laboratory errors, patient demographic, sampling time, altering the protein binding, pathological factors, medication, and sampling errors, an individual capacity to dis- distribute the metabolism and excretion of the drug in the body. This will play a crucial role in therapeutic drug monitoring. And coming to the next slide, here the FTIR plays a crucial role with not a single individual at a single time. Not it is not uh, uh, varied in a large amount of people or concurrently used within a single person can be used a therapeutic range and the drug concentrations can be calculated by using uh, quantifying tools and the software with advancements of FTIR. It is initially selection of dosing of the drug, and interpatient variability and absorption of metabolism. Next slide. And poor responses. Next, next slide. Next slide. Next slide. Poor responses to the therapeutic concentration, pharmacokinetics, which is not adequate addressing the drug interactions, where a suitable analytical technique is a blood rock of the drug analysis. And some of the drugs which are proven for clinical values, amikacin, carbamazepine, digoxin, and gentamicin are the examples. When coming to the case study of phenytoin, next slide, next slide. When phenytoin is administered uh, to 52 years old man for a complex partial epilepsy, the phenytoin, by varying the dose, she was stabilizes. Increasing with 750 grams, she stabilizes with no sutures and no toxicity for next 2 years, where the patient uh, ideal phenytoin levels were near an upper end of the normal range is 18 to 20 mg per liter, where therapeutic drug monitoring helped to tailoring the dose to balancing the effectiveness and safety. One side doesn't fit all the drug therapies in individual response matters. And coming to the next slide, FTIR transreflected microspectroscopy studying on normal breast cell lines after exposing to the protein green. Here, the pathological condition or biochemical changes which are observed in these breast cell lines, MCF 10A, whenever it is irradiated, it will label free FTIR was used. The technique to analyzes the absorption of biological molecule inside the structural and composition change in the cell can be seen, where e-microscopic slides are silver-coated reflected substrates compatible with both culture and trans-reflected FTIR measures. where dose-induced biochemical changes, spectra reveals the wave number and the intensity shifting with the key bands. When you're observing these band ranges are with slight changes when comparing to the control. And coming to the next slide. Here, amide it indicates the change in protein of secondary structures where lipid bands altering the membrane fluidity uh, in the breast cancer cell line, where it undergoes protein hepatosis, where the characteristics of vibrational bands are mostly notable for amide uh, 1 and amide 3 regions, indicates that protein in secondary structures and the lipids membrane fluidity bonds which are associated with cellular stress and apoptosis, where transreflected mode of micro FTR spectrum gives a powerful analytical tool for radiation biology and potential application for radiotherapy monitoring of biomedical diagnostics, cell-based pharmaceutical testing, and foundation for broad clinical adoptions are going on at present. Next, screening of tuberculosis based upon the proteins which are pathological conditions. The absorption bands of the proteins and the lipid region is 3,500 to 3,000, 2,900 to 2,800 centimeter inverse, 1,700 to 1,500 centimeter inverse were the evidence of two groups for identifying of the uh, TB protein in affected persons. When you're seeing the spectrum of absorption versus wave number, here the carbohydrates range and the proteins range and the lipids range can be visualized, where the diagnostic and the area under the curve and also can be achieved at, in this FTIR spectroscopy by using outperformancing of ATR. It is insensitive and it gives a detailed information. When coming to the next slide, micro Fourier transformer infrared reflectance spectroscopy as a tool for probing IgA. In COVID conditions, uh, glycosylation, where it is a change in the acylation with a band of C double bond O at the region of 1702 to 1785, which correlating with a disease severity indicates that acylation and glycine and methylation esterification of carbonyl groups, which is indicated in this spectrum with red line, where blood serums are enabled with sensitive and multiplexing detection of biological changes in immunoproteins like immunoglobulin G, offering faster and low cost and scalability, approaching for biomarker discovery of disease monitoring in biological matrices, where the bands lies in 1689 to 1698 centimeter inverse for beta sheet, where deoxy ribose at 840 to 856 centimeter inverse, 1735 to 1785 centimeter inverse for lipids and glycocytic proteins, where 1 microliter of dilution serum undergoes for controlled humidity, humidity for detection of multiple biomolecules simultaneously and which is less dependent on reagents and international supply chains in suitable for pandemic responses and resources limiting settings. In coming to the next slide, when coming to the next slide, case study of next slide, Then coming to the next slide. Next slide. FTIR, brain cancers, brain injuries, biomarkers monitoring the diseases, neurodegenerative diseases can be assessed by using the FTIR technique, where which is provides utility in time sensitive and biological sensitive in medical scenarios where clinical diagnostic and forensic analysis for therapeutic drug uh, monitoring and biomarker discoveries. And coming to the next slide, integration of chemometrics and machine learning. This is the advanced technique in the FTIR where uh, chemometrics is an software like PCA and PCL regression. These are the statistical tools to perform the high sensitivity with improving the signal to the noise ratio, where enhancing the specificity uh, with drug quantification by reducing the noise and improving the signal separation, where AI integration, which is emerged for machine learning over a matrix interferences and improving the reproducibility of therapeutic drug monitoring SES. When coming to the uh, how it is uh, uh, revolutionarily using in drug monitoring techniques, where ATAR probes for continuous inline therapeutic drug monitoring, clinical and industrial environment, where it is in a portable IR devices are convenient for bedside or field-based application to enhance the accessibility, and chemometric algorithms to improve real-time decision to make accuracy and efficiency. When coming to the next slide, chemometrics data processing in FTIR therapeutic drug monitoring. Next slide. In chemometrics method, there is a meaningful extraction of information of complex FTR data to enhance the sensitivity and specificity, where the principal component is PCA, where it is in a differential, it can differentiate the healthier and nutritional deficient cells can be identified in spectra, where a PCLS regression model, which is an accurate prediction of metabolites and drug levels, provides a precise quantitative data. Multivariant analysis is improving the sensitivity and specificity of detection of complex in biological matrices. When coming to the next slide, the overall summary of FTR spectrum represent the transformation approach of therapeutic drug monitoring offers rapid and non-destructive analysis in biological matrices, advanced technique to provide unpredictable spatial and molecular insight. When it is coupled with chemometrics, emerging technologies like AI, the FTIR is an asset, revolutionized personalized drug monitoring and leading to improve patient outcomes and more therapeutic strategies. And these are the references for recent advancements. Thank you for the administration for giving this opportunity to present before you.
Okay. Thank you, sir. Thank you for your informative session. So, very good afternoon to all the participants, today's guest speakers, Surendra sir, and all my dear colleague friends. I am again very much thankful to all the participants who joined with us again, and Surendra Babu Garu for keeping our invitation and part of this program. Thank you, sir. So, sir explained nicely about the fundamental of Okay, fundamental of spectroscopy, principle, instrumentation nicely, and also explained importance of FTIR spectroscopy in chemical as well as pharmaceutical industry. And nowadays we know how pharmaceutical and chemical industry there is many instruments are helpful, especially FTIR and application in along with chemical pharmaceutical, how FTIR helpful in medical science. He explained excellently how in medical science, especially the one or two case studies in which he mentioned the phenytoin case studies, where with how with the FTIR and the therapeutic drug monitoring helps in dose adjustment for a patient. So really, it is very much helpful along with chemical and pharmaceutical industry. Usually, you know, this FTIR technique and other instrumentation helpful in chemical as well as pharmaceutical industry as a pharmacy professional. But how it is helping in medical professional in treatment and therapeutic drug monitoring, it is really helpful to all the health professional and all the patient aspect of view. So, sir also explained the integration of chemometrics nowadays, which is one of the most important field. Integration of chemometrics and machine learning, which is also booming sector nowadays. And I hope all the participants enjoyed the session with some insightful and informative knowledge. So thank you, sir, for your information. Once again, I'm thankful to all the participants. Thank you, sir. So now I request all the participants, you can leave and we'll follow up for your participation certificate. Thank you all.
Thanks. Banning